In the world of hypercars, few names carry as much weight as Bugatti. Known for building some of the fastest and most expensive cars ever made, Bugatti represents perfection, exclusivity, and control. Every part of Bugatti is carefully designed, tested, and approved by the company itself. Because of this, Bugatti keeps a very tight grip on its parts and repairs. Normally, if something breaks, owners are expected to go through official Bugatti channels, no matter how expensive or difficult the process may be. But this story challenges that idea completely. When YouTuber and car builder Mat Armstrong began rebuilding a crashed Bugatti, he ran into a wall that most people would never expect. Bugatti refused to sell him parts. Not just one or two items, but almost everything he needed. Bolts, brackets, pipes, and other important components were simply not available to him through official means. Emails were ignored, requests were turned down, and access to parts was blocked. The message from Bugatti was clear. Without their support, this rebuild should not be possible. For most people, that would have been the end of the project. A car like this is not something you can fix with random tools or simple replacements. It is a machine built with extreme precision, and even small parts are important. But instead of giving up, Matt decided to take a completely different approach. If Bugatti would not sell him the parts, he would find another way. This decision changed everything and turned the rebuild into something much bigger than just fixing a damaged car. It became a story about problem-solving, creativity, and challenging the limits set by manufacturers. As the rebuild progressed, a surprising pattern began to appear. Every time a part was unavailable, Matt and his team found a replacement. Sometimes they repaired the original part. Sometimes they built a new one from scratch. And sometimes they discovered that the same part existed in a completely different car at a much lower cost. What made this even more interesting was that many of these solutions were not just cheaper, but in some ways better for the situation. This does not mean Bugatti's engineering is poor. In fact, Bugatti designs its cars for mass production at a very high level, with strict safety and quality standards. However, those same standards can also limit flexibility. When you build thousands of parts using the same process, you cannot always customize or improve each one individually. On the other hand, when a single skilled engineer or fabricator works on a specific problem, they can focus only on that one part and make changes that are not possible in a factory setting. This difference between large-scale manufacturing and individual craftsmanship is at the heart of this story. It shows how sometimes thinking outside the system can lead to unexpected results. As we go deeper into this rebuild, we will look at several key components that Bugatti refused to provide and how Matt and his team managed to replace them. Each example reveals something new, not just about the car, but about how modern automotive engineering works. It also raises an important question. Do you always need the original manufacturer to fix something, or can knowledge and creativity be just as powerful? This is not just a story about a car. It is a story about breaking limits, finding solutions, and proving that even the most controlled systems can be challenged with the right mindset. One of the most important and challenging parts of the rebuild involved a structural component that most people would never even notice, yet played a huge role in the condition of the car. This was the engine and gearbox mounting bracket, a solid piece of cast aluminum designed to hold the heart of the car firmly in place. In a machine like the Bugatti Chiron, where power levels are extremely high and tolerances are very tight, even a small failure in a structural part can cause serious problems. During the crash, this bracket cracked under stress. That crack allowed the engine to shift slightly forward, which then created a chain reaction of issues throughout the car. Fixing this single component was not simple. It required separating major sections of the vehicle just to access it. Naturally, the expected solution would be to order a brand new replacement from Bugatti. However, as with many other parts in this rebuild, that option was not available. Even if it had been, the replacement would have been exactly the same design as the original, including the same manufacturing limitations that may have contributed to the failure in the first place. Cast aluminum parts are strong, but the casting process can create small internal gaps or weak points that are difficult to avoid when producing parts at scale. These tiny imperfections are usually not a problem under normal conditions, but in extreme situations like a crash, they can become points of failure. Instead of accepting that limitation, Matt and his team chose a different path. They decided to repair and improve the original bracket rather than replace it. This is where skilled craftsmanship made a big difference. The damaged bracket was given to a fabricator who carefully prepared it for welding. The aluminum was heated to the correct temperature, and a proper fill of material was used to ensure a strong and clean repair. But the process did not stop there. After fixing the crack, they looked deeper into the structure of the bracket and identified areas where extra strength could be added. Using simple materials like cardboard, they created templates to design reinforcing ribs that could be fitted into the bracket. These reinforcements were then welded into place, effectively strengthening the part from the inside. This kind of modification is something that large manufacturers like Bugatti cannot easily do during production because it would increase cost, complexity, and production time. In a factory, parts need to be consistent and efficient to produce, even if that means accepting small compromises. In this case, working on a single part allowed the team to go beyond those limits. The result was a bracket that was not only repaired but also reinforced in a way that directly addressed its original weak points. Instead of replacing the problem, they solved it. Another important factor was cost. A new structural component from Bugatti would likely cost a very large amount of money, possibly reaching into 5 figures. In comparison, the repair and modification process required time, skill, and relatively low-cost materials. This showed that with the right knowledge and effort, it is sometimes possible to achieve strong results without relying on expensive factory parts. However, it is also important to understand that this approach requires expertise. Not every repair can be done safely outside of official systems, especially when dealing with high-performance vehicles. What makes this example special is a combination of skill, careful planning, and attention to detail. It highlights the difference between simply replacing parts and truly understanding how they work. By choosing to repair and improve the bracket, Matt and his team demonstrated that even critical components can be re-engineered when the right approach is taken. This moment in the rebuild set the tone for everything that followed, showing that the project was not just about fixing damage, but about rethinking how the car could be put back together in a smarter and more flexible way. After dealing with one of the most critical structural parts of the car, the rebuild moved on to something that is both highly visible and deeply connected to performance: the exhaust system. In a hypercar like the Bugatti Chiron, the exhaust is not just about removing gases from the engine. It plays a major role in airflow, sound, heat management, and even overall driving experience. Normally, if an exhaust system needs replacement, the only official option is to install a factory unit provided by Bugatti. These factory systems are designed to meet strict standards for noise, emissions, and durability, and they are built to match the exact specifications of the car. However, they are also extremely expensive and offer no room for customization. In this rebuild, getting a factory replacement was not possible, so Matt and his team had to look for an alternative. Instead of trying to copy the original design, they decided to create something completely new. This decision opened the door to a level of customization that would never be possible through official channels. To begin the process, the car was digitally scanned using 3D technology. This allowed the team to map out the exact shape and dimensions of the space where the exhaust system would sit. With this data, they were able to design a system that fit perfectly within the car, while also improving airflow. Custom flanges were created using CNC machining to ensure that the new exhaust would connect seamlessly to the existing engine components. This level of precision was important because even a small misalignment could cause performance issues or leaks. One of the most interesting features of the new system was its layout. Instead of following the standard design, the team introduced an X-pipe configuration. This means that the exhaust gases from both sides of the engine cross over each other before exiting the car. This type of design is often used in performance vehicles because it can improve exhaust flow and create a smoother, more balanced sound. The system was then split into multiple points, creating a unique setup that had never been seen on this model before. Another major addition was the use of a valvetronic system. This allows the driver to control the sound of the exhaust, making it quieter for normal driving and much louder when performance is desired. This feature adds a level of flexibility that the original system did not offer. While building a custom exhaust, it was also important to consider legal and environmental factors. The team made sure to keep the primary catalytic converters and all necessary sensors in place, so the car would still meet basic emission requirements. However, some secondary restrictions were removed to improve airflow. This balance between performance and compliance shows that it is possible to modify a car responsibly while still achieving better results. The final outcome was an exhaust system that not only fit the car perfectly, but also offered improvements in multiple areas. It allowed better airflow, produced a more unique and aggressive sound, and gave the driver more control over how the car behaves. At the same time, it highlighted an important difference between factory production and custom work. Manufacturers like Bugatti must design parts that work for every customer under all conditions, which often limits how extreme or specialized those parts can be. In contrast, a custom-built solution can focus on the needs of a single car and a single owner. This does not automatically make it better in every way, but it does create opportunities for innovation. In this case, the inability to buy a factory exhaust did not stop the rebuild. Instead, it pushed the project in a new direction, resulting in something unique that would not exist otherwise. It showed that when standard options are removed, creativity can take their place, sometimes leading to results that are more personal, more flexible, and more interesting than anything available from the original manufacturer. After working through complex and highly engineered components like the structural bracket and the custom exhaust system, the rebuild revealed something surprising. Sometimes the most interesting solutions come from the simplest problems. One such example was a small but important part of the cooling system, the coolant overflow pipe. In a high-performance machine like the Bugatti Chiron, cooling is extremely important because the engine produces a massive amount of heat. Every pipe, hose, and connector in the system has a specific role in maintaining the correct temperature. During the accident, when the engine shifted forward due to the damaged mounting bracket, it crushed a thin metal pipe that carried coolant to the overflow reservoir. The pipe was flattened and completely unusable. Normally, replacing such a part would be simple. Just order a new one from the manufacturer. However, as seen throughout this rebuild, getting parts from Bugatti was not an option. The specific pipe was not available through any accessible channel, which meant the team had to come up with an alternative. Instead of searching for an identical metal pipe, they chose a much simpler solution, a rubber hose. At first, this might sound like a downgrade. After all, replacing a precisely engineered metal component with a basic rubber hose seems like a step backward. But when examined more closely, the solution actually made a lot of sense for the situation. The team selected a hose with the correct internal diameter and pressure rating to handle the coolant flow. It was cut to the right length and fitted securely onto the existing connections using standard clamps. The installation took only a few minutes, and the cost was very low compared to what a factory part might have been. What makes this example interesting is not just the simplicity of the fix, but how it changes the way we think about durability. The original metal pipe failed because it could not handle the force applied during the crash. Metal, while strong, can deform permanently when pushed beyond its limits. Once bent or crushed, it does not return to its original shape. A rubber hose behaves differently. It is flexible and can absorb some level of impact by bending rather than breaking. In a situation where the engine moves slightly or external forces are applied, the hose can adjust instead of failing completely. This does not mean that rubber is always better than metal. In many cases, metal pipes are preferred because they are more resistant to heat and wear over long periods. However, this example shows that different materials have different strengths, and sometimes a simple material can perform better under certain conditions. It also highlights an important idea in engineering. The best solution depends on the problem you are trying to solve. In this case, flexibility and ease of replacement were more valuable than rigidity. Another interesting point is how quickly this problem was solved compared to other parts of the rebuild. While the bracket required careful welding and the exhaust system needed advanced design and fabrication, the coolant pipe was fixed with basic tools and easily available materials. This contrast shows that not every challenge requires a complex solution. Sometimes, understanding the function of a part is more important than copying its original design. By focusing on what the pipe needed to do, carry coolant safely from one point to another, the team was able to find a practical and effective alternative. This moment in the rebuild serves as a reminder that engineering is not always about making things more complicated. In many cases, it is about finding the simplest solution that works reliably. It also reinforces the overall theme of the project. When official options are limited or unavailable, creativity and practical thinking can lead to solutions that are not only effective but also surprisingly efficient as the rebuild continued. One of the most talked about moments came from something incredibly small but extremely important: a single bolt. In a car as complex as a Bugatti Chiron, every fastener has a purpose, and even the smallest component plays a role in holding the entire structure together. During the reassembly process, the team encountered an issue that could easily happen in any workshop. While tightening bolts on the underside of the car, one of the fasteners was accidentally over-torqued. This happened because not all the bolts in that area were the same size or specification, and the difference was not immediately noticed. As a result, the bolt snapped clean in half. This might seem like a minor setback, but in a high-performance vehicle, especially one built by Bugatti, even a single broken bolt could become a serious problem. The natural expectation would be to order a replacement directly from the manufacturer, ensuring that the exact same specification is used. However, just like with the other components in this rebuild, accessing official parts was not possible. The specific titanium fastener was not listed in any public catalog, and there was no straightforward way to purchase it through normal channels. This created a situation where the team had to think carefully about how to replace it safely and correctly. Instead of guessing or using a random substitute, they took a more thoughtful approach. They carefully measured the original bolt, checking its diameter, thread pitch, length, and material type. These details are crucial because using the wrong specification can lead to improper fitment or even structural failure. After confirming the exact requirements, they searched for an equivalent bolt that matched those specifications. Surprisingly, they found a suitable replacement available through a common online marketplace. It was a titanium bolt with the same measurements and strength rating needed for the application. The cost was extremely low compared to what one might expect for a part used in a multi-million-pound car. It arrived quickly and was installed without issue. What makes this situation interesting is not just the price difference, but what it reveals about how parts are sourced in the automotive industry. Even in very expensive vehicles, some components are not entirely unique. Manufacturers often use standardized parts when possible, especially for items like bolts and fasteners. These parts must meet certain engineering standards, but they do not always need to be exclusive to a single brand. This means that with the right knowledge, it is sometimes possible to find identical or equivalent components outside of official channels. However, it is very important to understand that this process requires accuracy and responsibility. Not all bolts are the same, and choosing the wrong one can lead to serious consequences. In this case, the team made sure to verify every detail before installing the replacement. This careful approach ensured that the new bolt would perform exactly as needed. Another interesting aspect of this moment is how it changes the perception of value. Many people assume that parts from high-end manufacturers are always superior simply because of the brand name. While these parts are designed to meet strict standards, their cost can also include factors like branding, exclusivity, and limited availability. Finding a similar part at a much lower price does not automatically mean it is better, but it does show that price and performance are not always directly connected. This example highlights the importance of understanding what a part actually does, rather than focusing only on where it comes from. By identifying the correct specifications and sourcing a matching component, the team was able to solve the problem quickly and effectively. This moment reinforces the idea that knowledge and attention to detail can sometimes be more valuable than access to expensive or exclusive resources, especially when working on complex machines where precision matters most. As the rebuild moved closer to completion, one final discovery changed how many people viewed the entire project. Unlike the previous examples, this was not about repairing or replacing a damaged part, but about understanding where a part originally came from. While reconnecting components around the engine, the team took a closer look at the starter motor, the device responsible for turning the engine over when the car started. In a hypercar like the Bugatti Chiron, powered by a massive quad-turbocharged engine, most people would expect every component to be highly specialized and completely unique. After all, this is a machine that produces extraordinary levels of power and performance. However, when the part number on the starter motor was checked, the result was completely unexpected. The same part number was linked to a starter motor used in a much more ordinary vehicle from Volkswagen. Specifically, it matched a unit commonly found in a 1.9 TDI diesel engine, a type of engine that had been used in millions of everyday cars around the world. This meant that the component responsible for starting one of the most advanced hypercars ever built was, in fact, the same as one used in a regular family car. This discovery highlights an important aspect of modern automotive engineering. Even the most expensive and exclusive vehicles are often built using a combination of custom-designed parts and widely available components. Manufacturers do this for several reasons. Using proven parts that have already been tested in other vehicles can improve reliability and reduce development time. It also allows companies to focus their resources on designing the parts that truly need to be unique, such as the engine, aerodynamics, and advanced systems. In this case, the starter motor did not need to be completely redesigned because an existing solution was already capable of performing the required task. From a practical point of view, this meant that if the starter motor ever needed to be replaced, it could potentially be sourced from a regular parts supplier rather than through official channels. The cost difference would be significant, as standard components are usually much cheaper and easier to obtain. However, this also raises questions about how parts are priced and marketed in high-end vehicles. When a component is associated with a luxury brand like Bugatti, its perceived value often increases, even if the underlying part is not unique. This does not mean that the manufacturer is doing anything wrong, but it does show how branding and exclusivity can influence pricing. Another important point is that compatibility alone does not guarantee suitability in every situation. Even if two parts share the same design, factors such as wear, condition, and proper installation still matter. In this rebuild, the original starter motor was functioning correctly, so it did not need to be replaced. The discovery was more about understanding the car than fixing a problem. It provided insight into how different components come together to create a complete system. It also challenged a common belief that every part of a hypercar must be rare or impossible to find. This moment brought a new perspective to the entire project. Up until this point, the focus had been on finding alternatives to unavailable parts. But here, the realization was that some parts were never exclusive to begin with. They were simply hidden behind branding and limited access. This does not reduce the value of the car as a whole, but it does change how people think about it. It shows that even the most advanced machines are built on a foundation of shared engineering and practical solutions. As the rebuild reached its final stages, this discovery served as a reminder that knowledge can reveal opportunities that are not immediately obvious. By taking the time to investigate and understand each component, the team was able to see beyond the surface and uncover details that added depth to the story. In the end, the starter motor was not just another part of the car. It became a symbol of how perception and reality can sometimes be very different, especially in the world of high-performance engineering. As the rebuild of the Bugatti Chiron finally came together, what stood out was not just the fact that the car was running again, but how it was achieved. Every major challenge in the process followed a similar pattern. A part was either unavailable or restricted by Bugatti, and instead of stopping the project, Matt and his team found another way forward. Sometimes that meant repairing damaged components. Sometimes it meant building new ones from scratch, and other times it meant discovering that the same part existed in a complete